So in previous video we did this by hand. If you are looking at how to do this in your calculator, let's go ahead and grab the calculator up. You're probably going to want to use either table or graph, and I'll just show you both. So table, most people prefer this one. Remember, you don't have to enter in the first bit, it's just what it's equal to. So we're looking at our rule, and I'm going to not worry about the r equals, but I'm going to get the rest of it in here. And this is a good example of no matter what the variable is, if you got a's and p's or x's and z's and m's, doesn't matter, you're always going to use this button under the red one there for your variable. So we will enter in 0.5 x squared minus 0.5 x, and that is our rule. We'll go to table, and we will take a look at starting at 1 and going down. And again, not going to help us out here because we need to look to see where we have 7 airports. So remember that trick from the linear video. Exit yourself backwards and go to set. Set tells you, or allows you to tell the table how much you want to know. So we can start at 1, that's fine, but we need to get to a lot more if we're going to get 7 and potentially 55 roots in the next problem. So I might just bump that up to 10, see what happens. And keep my step the same. Go back to table. And now I'm looking for 7 airports, so if I scroll down to find when x is 7, I can see that I have 21 airports, and that is exactly what we solved using just basic math skills and algebra there. So again, the x is the airports, and the reason x is the airport, again, if you go back up and look at your original table, we see that airports are first, the routes are second, so we have airports are the x variable. And again, we can use table to figure out how many airports we have if there's 55 routes, but this is looking in the y column. So let's go down. 10, we don't yet have enough cities there. So let's go back, set, and give ourselves even more. How about 20? And again, you can just take a stab at it. You don't have to know. So I'm just going to give me more, see if I can find it. Table, and I'm looking to find the number 55 in the y column. Oh, there it is. Right, so 55, 11 airports. And that will work for us here for solving out these problems. And just another strategy for you guys to see this, just to be aware of the graph function. It has quite a few cool tools in it as well. So again, if you go into graph, it might or might not, but probably won't, like the fact that it's copied the equation in that you put into table. So with condition error, just retype your equation. 0.5 x squared, oops, not plus, minus 0.5 x. Go ahead and draw it up. We can see things pretty well there. And we're going to go into gsolve because that's where everything exciting can happen if we need to solve things. That's F5. And I'm going to arrow over here because I'm looking for xcalc and ycalc. So these are kind of interesting things for us. Let me just put this down here. So graph, gsolve, xcalc. This is when you want x, and ycalc when you want y. So let's see how that looks. In this first problem here, if there are 7 airports, well, that's my x, and I want to know my y. So I'm going to go to ycalc because I want to know a y value, but I know an x value, and so pay attention to this. If you click on xcalc by accident because you've been given x, it's going to ask you for a y, but you don't know y. So again, we're looking for, go back, we are looking for the y value, the number of routes, so we're going to click on y, and we're going to put in 7 because we know we have 7 airports. What's our value of y going to be? So put it in, and if it tells you argument error or not found, that's okay. Go back, exit, draw, and you need to get your graph window to be a lot bigger. So I'm going to start at 0, and I'm going to go up to, I don't know, we'll say 20 on the x scale. And on the y, I'll start at 0 and go up to, let's try 100. Just putting in numbers that I think might work for me, just keep making them bigger. So here I see more of the graph. gsolve again, arrow over. My ycalc, I'm looking for y, is going to be, in this case, 7 for x. And there, now it's able to find it for us. So you can see when x is equal to 7, y is equal to 21. So that's an important thing in there. and draw gsolve for the next problem. We're looking for x in this case, how many airports, so xcalc, and then we put in 55 roots. We can see that we have x is equal to 11. And this, what I'm going to show you guys now is just kind of another random tip for you that you'll use in other problems. In this particular context, we're talking about real life things like airports, so there's not going to be any negative airports. But every once in a while with quadratics, it is helpful to be aware of symmetry. So if I did negative 20 to 20 on my x-axes, you can see I get a nice parabola here. So in this case, if I do gsolve, arrow over, and again I look for an xcalc when y is equal to 55, what's the first solution it gives me? Negative 10. And that's in fact the first solution we found using our algebra here. But it doesn't make sense in the context of an airport because you wouldn't have negative 10 airports. But if you're using a parabola and you see a lot of the graph, it's going to just start with the first one that it can find. And in this case, it's the negative solution, which doesn't help us. But it's easy to get to the positive solution if there's more than one. Just arrow over using your big gray replay button here. So just arrow over and you get to the next one, which is 11 and 55. So you can see how you can just arrow between those two solutions. So be aware of that for parabolas. There'll be two solutions potentially, but pay attention to which one actually matters for your context. So again, you can use table, just searching for the one you need, or you can go into graph and use gsolve with xcalc or ycalc.